So here's problem number 25 from section 11.2. It is a geometric series, and I want to determine if the geometric series is convergent or divergent, and then I need to find the sum. So I've not looked at this problem before, at least not in a while, and I'm thinking this when I see the problem. I'm going to have to use a little bit of algebra to get it in a form where I can answer something about this problem. So I'm going to rewrite this. This sum as n goes from 1 to infinity. Now that e to the 2n, I'm thinking about the laws of exponents back from your algebra class several years back, and I'm seeing it's 2 times n. What property of exponents can I use to rewrite that in another form? Well, here, this is the one I'm thinking of. It's a to the m times a to the n. No, it's not that one, is it? Because what is that on the other side? A to the m plus n. So that's not it. But the one that does the multiplication would be a to the m to the n, the power to a power. And what is that going to be? A to the m times n. So with this one, I have the right side of this, and I'm going to rewrite it into the left side. So I'm thinking of this. I'm going to write e squared to the n over 6 to the n minus 1. And I'm going to force it into the form for geometric with in this form. I'm going to take number 25 and put it in the form for geometric series, which was the sum of a times r. Some books use n minus 1, some books use an n right there, and I think your book used n minus 1, but I'm gonna want to verify that. It does, n minus 1, and then they'll start in at 1 and go to infinity. So I want to put it in that form, and I'm seeing I have e squared. Now that's just a constant. In fact, what is e squared? What is it? What is the decimal approximation for e squared?
2.7.
E squared, that's e to the first. E squared is 7.389. I've done that a lot through the years. Okay, e squared is about 7.389. And then the bottom, I'm going to have 6 to the n minus 1. I'm already looking at this problem, and I'm thinking this one is going to diverge. Not quite in this form yet. But what I can do is take this top part. In fact, the top part, we could just say it is e squared. I'm going to take that I'll leave it like this for now. 7.389 to the first power times 7.389 to the n minus 1 over 6 to the n minus 1. Now I used this property a bit. I had to the power n, and I said, okay, if I do 7.389 to the first times 7.389 to the n minus 1, I would come back and add these exponents. There's the n, if I use this property of exponents. So what I have here is that 7.389 is going to be a. In fact, if you want to write it as e squared, you can write it as e squared. That would be more correct. I'm leaving it like this because I want you to see, here is the r, 7.389 over 6, that's to the n minus 1. So what is r?
Greater than 1.
It's greater than 1. That's exactly what I need to know. R is greater than 1. In fact, and if it was equal to 1, it would also do what? Diverge. This series diverges. Diverges since R, now I could write again e squared over 6. I wrote it as 7.389, so you would see this fraction that's formed is bigger than 1, greater than 1, and I could put greater than or equal to 1, but certainly it's greater than 1, so this series diverges.